Okay, guys, sorry for the technical disruption. We will continue with our discussion from just now. Okay, so just now we were at question 2.1, the Venn diagram. Okay, so let's go back to part 4 again, and let's try to discuss this part. Okay, so for part 4 again, we want the greatest value of A intercept B prime intercept C. Okay, so what we are looking at here, okay, is, as I say, a three event Venn diagram, A, B, and C. Okay, so for me, okay, I will break it into A intercept B prime intercept C. Okay, you might think that there's nothing different in me writing this way. Okay, so let me put a bracket here. So what I'm considering is actually A intercept B prime intercept C. B prime intercept C was obtained from my part 3. Okay, and this answer here was 4 over 21. Okay, so if I were to look in terms of the Venn diagram, okay, A, okay, is your circle A. B prime intercept C. Where is B prime intercept C? B prime intercept C is actually this crescent over here. Okay, it's actually this crescent over here. So what I want to find out is actually the intersection between A and this crescent. And what is the greatest and the least value that we can have. So as I mentioned just now, all right, okay, the greatest possible case, the greatest scenario. What is the greatest scenario? The greatest scenario is when I'm able, okay, to squeeze this crescent into A itself. Okay, because then this will have the greatest overlap between the crescent and the A. So for this to actually happen, all right, we need to compare between A intercept B prime, which is today 1/3. What is A intercept B prime? A intercept B prime is actually this part over here, this bigger crescent. We must ensure that this A intercept B prime, it is bigger than 4 over 21, which in this case, yes, it is. Therefore, okay, we can say that the greatest scenario is possible. Okay, so the greatest overlap that can happen is actually 4 over 21. How about the smallest? As I mentioned just now, if you talk about the smallest, in terms of the smallest, okay, A and B don't change. A and B is the same. But if you're talking about the smallest, means there's completely no overlap at all. That means my crescent is outside here. Okay, this crescent is outside here. So the overlap is actually 0. And the question is it possible for it to be 0? Okay, let's look at the space. Let's look at the space that is outside of A and B. This space here is actually 1 minus P A union B. And P A union B, okay, is given to be 6 over 7. So this is actually 1 over 7. So the yellow color space is actually 1 over 7. But our crescent over here, our dear friend crescent, has an area of 4 over 21. So is this scenario possible? The answer is no. We can't even fit the crescent in the yellow color. Yellow color only 1 over 7, but the crescent is 4 over 21. Meaning to say, okay, we got to change it a bit. Okay, how can we change it? I were to redraw it, okay, because A A and B is fixed. A and B is fixed. So if the crescent cannot fit completely outside, meaning to say that some parts of the crescent must be inside A, such that the only possible part that is outside must be 1/7, which is limited by this condition over here. So therefore, if 1/7 is outside, how about the inside? Inside will be the overlap, right? Between the crescent and A, which is what we want. So if I take 4/21, which is the crescent area, minus away 1/7, which is the maximum possible value that you can squeeze outside of A and B, it will give us 1/21. Therefore, the smallest value is 1/21. And the biggest value is 4/21. Okay, this kind of analysis is certainly not simple in the exam. Okay, there's a few questions that has come out already for this kind. Okay, if you really want to back these marks, the only way is to practice and memorize it. But if you think this marks itself is not worth your time, probably this we definitely for this question I can solve it 1, 2, 3. For part 4, probably it's going to be a 3 marks. This 3 marks I don't need. Okay, remember, for those who have attended my lessons, there is always a strategy to acing the JCA levels. It's not about scoring 100%. Nobody can score 100%. If I were to sit in the exam, I don't think I can score 100% also. It's about strategizing yourself and maximizing the marks. Okay. So having said that, that's it for this Venn diagram question, okay, which I feel is one of the hardest question that has ever been. Okay, let's move on to the next part, which is 2.2, tree diagram. Okay, so again, tree diagram is another tool for us to analyze the question. Okay, the essence or the whether or not you can score for this kind of question lies in the systematic approach of drawing the tree. If you can draw the tree systematically, the question is yours. But a lot of students, they can't do that. They anyhow do it. They fail to categorize the different conditions. So for example, in this case, okay, this is a meeting question. In the preparation of upcoming event, a student management is considering having a meeting on Friday, Saturday, Sunday. The probability that the meeting is conducted on Friday is 1/6. On the other days, the probability on the meeting is conducted when the meeting has already been conducted on the previous day is 2/5. And the probability that is conducted when the meeting has not been conducted on the previous day is 1/3. Okay, can. So how should we draw this tree diagram in a very systematic way? Okay, so there is clearly 3 days, right? So 3 days means I need to have 3 different columns. Okay, which is Friday, Saturday, then Sunday. So on each of the day, meetings can happen and meetings don't happen. Okay, so this column here is the date. And the rest of it, this row is date and the column is actually yes or no. Yes or no? It's a simple question. So today on Friday, okay, so if it is a yes, the probability will be 1/6. If it is a no, the probability will be 5/6. On Saturday, again, yes or no, yes or no. And on Sunday, again, yes or no, yes or no, yes or no, yes or no. So remember, there should be 2 so-called variables. One in your row and the other one in your column. Okay, this will make your tree diagram very systematic. Okay, so on Saturday itself, if it is a yes, okay, the probability will be actually 2 over 5, because the probability that the meeting is being conducted when a meeting has already been conducted on the previous day is 2 over 5. So this is 2 over 5. And take note, I want to highlight this again. This 2 over 5 is actually conditional probability. Whatever that you put in your tree diagram is conditional probability. This 2 over 5, if you write it out, it will be meeting given meeting, which is 2 over 5. The probability of meeting yes, and given that the previous day is meeting, is 2 over 5. So on the other hand, this will be 3 over 5. So no, okay, this will be 1/3 as given by the question, and this will be 2/3. Okay, and so we will continue to fill in with the same conditional probability, 2 over 5, and this will be 3 over 5. Okay, this will be 1 over 3, this will be 2 over 3. Okay, this will be 2 over 5, this will be 3 over 5, this will be 1 over 3, this will be 2 over 3. So for part 1, we can answer the question. Once this diagram is out, the question is very simple. Meeting is conducted on a Sunday. So we trace which one will give us a Sunday path. Okay, so which one will give us a Sunday path? Okay, it can be yes, yes, yes. It can be yes, no, yes. Okay, and so on and so forth. Okay, so the probability I can write down here, it will be yes, 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 plus probability of yes, no, yes, plus probability of no, yes, yes, plus probability of no, no, yes. Okay, so you can multiply it accordingly, okay, according to the tree diagram. Remember, let me show an example. When I use yes, 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 it will be 1 over 6 times 2 over 5 times 2 over 5 plus dot, dot, dot. This over here is conditional probability. When I multiply like that, it's conditional. It doesn't mean it's independent. Whenever you use tree diagram, there's a high chance it's conditional. So if you do this, your answer will be get 0.356. Okay, same thing for part 2. Okay, find the probability that is being conducted on Friday given that there's a meeting on Sunday. So since it's conditional probability, okay, we'll write down the formula. Okay, no on Friday given that yes on Sunday. Apply the formula. Will be probability of on Friday no intercept Sunday yes over probability of yes on Sunday. Okay, so to get the probability is very simple. Just again look at the tree diagram. Friday no, Sunday yes. So which one is Friday no, Sunday yes? Let's trace it. Friday no, we'll start from here. No. Okay, it can be yes, yes. Or it can be no, no, yes. Okay, so the probability again can be no, yes, yes, plus probability of no, no, yes, over yes on Sunday. Yes on Sunday was actually computed in part 1, which is 0.356. So if you put in the values, you'll get the answer of 0.832. Okay, so there's not much tips I can give you for tree diagram. Most students think that they know it since secondary school. Okay, but the true essence or making it difficult from the assessment point of view is to give you two variables. So if you can draw it systematically, tree diagram is actually chicken feed. Okay. Okay, so the last technique or the last category of question is actually the PNC approach. Let me try to scroll this down. I can't scroll this. Okay, let's not try to touch this. Okay, the last category of question is actually the PNC approach. Okay, we use this example to show. Okay, so individual letters of parallel is printed on identical cards and arranged in a straight line. Okay, find the number of arrangements such that there's no restriction. Okay, so firstly, this is a standard question, okay, of vowels and consonants. Okay, so today, most importantly, we are looking at the repeats. Which are repeats? Okay, we have two, the repeats wise. Okay, color. Okay, we have two A's and three L's. Okay, so if in total we have 8 letters. Okay, that's first thing. So for A part 1, we want to arrange with no restriction. Okay, this is standard textbook question. It will be x factorial divided by 2 factorial times 3 factorial. Okay, this will give you 3360. Okay, 2 factorial because I have 2 repeated A's, 3 factorial because I have 3 repeated L's. Part 2. Part 2, no L's to next to another L. So in this case, we will use the thing called the slotting method. In the slotting method, as I mentioned in class, okay, we'll always arrange the separator first. Okay, do not arrange the separated first. It's going to give you a hard time. Always arrange the separator first. So today, we don't want L to be together. So L is the one to be separated. So the separator will be the 5 other values. Okay, so we'll arrange the 5 other values, 1, 2, 3, 4, 5. Okay, so it will be 5 factorial. And when we arrange these 5 values, there's 2 repeated A's inside. So you need to divide by 2 factorial. Multiply by, we'll slot in the L's. So how many slots are available? 1, 2, 3, 4, 5, 6. 6 slots available. So 6 choose 3. We are not going to arrange the L's because they are the same. So this will give me 1, 2, 0, 0. Part 3. Okay. So for part 3, we need the arrangement to start and end with a consonant, and all the vowels are together. Let me clear this because this one needs space. So for part 3, okay, so in this case, we must know that we have 3 vowels and 5 consonants. Okay, so 3 vowels. We want the 3 vowels to be together. Okay, and the 5 consonants must be in the front. So then the question is, can we have a single line equation that can represent all cases? That means, let's say, this is the negative demonstration. I have 8 letters, 1, 2, 3, 4, 5, 6, 7, 8. So on the consonant in the first one, I can just, oh, okay, 5 choose 1. Then last one will be 4 choose 1. Okay, then I group the vowels together. So just vowels together, which will be, which are the vowels? A, A, E. And then I arrange. So can I just write as 5 choose 1 times 4 choose 1 times in the middle will be 1 group, 2 group, 3 group, 4 group. 4 factorial times 3 factorial divided by 2 factorial. For those who are good at P and C, you know that this is wrong. Why? Because this single scenario cannot represent all cases. There will be the what ifs. What if the first one is L? What if the last one is L? Because this will affect how we arrange the middle part. It will not be as simple as 4 groups. If the first one is L, that means in the middle, I will have 2 other L's. I need to divide by 2 factorial. If both are L's, then it will be 4 factorial. If none are L, then I need to divide by 3 factorial. So this is where the cases come in. Why is it difficult? Because we need to logically think of the cases. So once we know the cases, we can split it into 3 cases. Case number 1. Okay, case number 1 will be 1L either at front or back. Okay, so front or back, 2 choose 1. Put 1L in. Okay, can. So once I put 1L in, okay, the other slot at the back cannot be L anymore. Okay, so the other slot at the back is either P or R. Okay, so P or R, okay, again will be 2 choose 1. Okay, so in the middle, okay, we need to do 4 factorial. But in the middle, because 1L is either in front or at the back. So in the middle, when you arrange the 4, you arrange 2 L's. So you need to divide by 2 factorial. Okay, and then finally the grouping AAE, I can also arrange them, but because there's double A, so I need to do divide by 2 factorial. So this will be 1, 4, 4. Okay, so you must follow the explanation in order to understand. And this is the reason why sometimes it's also difficult to give the working marks. Case number 2. Okay, so case number 2 will be both L's, front and back. So if both L's front and back, then we don't need to bother about front and back. In the middle, it will just be 4 factorial. And when we do the 4 factorial in the middle, there will be 1 L inside only. So there's no other repeats. So the groups of 3 vowels, again, we can arrange them, but in the group of 3 vowels, there's 2 A's, so I need to divide by 2 factorial, 2. So the last case, case number 3, no L's. So if there's no L's, okay, then so the front and back can only be P or R. Okay, but again, they can switch places, so the P and R can switch places. In the middle, when we arrange the 4 factorial, there will be 3 L's. And for the group of 3 vowels, 3 factorial divided by 2 factorial because of the 2 A's, and this will be 24. And if I add everything together, give me 240. Okay, so this is for part 3. Okay, I wouldn't say it's very easy, okay, but this is actually quite standard also. If you've done your tutorial, you've gone through the thinking process 1 or 2 times, 3 or 4 times, you should be able to grasp it. Okay, so the last part, B. Now the cards are placed in the bag. Okay, and Tom draws a card randomly from the bag, 1 at a time. 4 cards are drawn without replacement. Find the probability that at least 1 vowel is drawn. Okay, so the keyword here, at least 1 vowel is drawn, means to say that if I want the probability, I can use the complementary case of 1 minus no vowel. Okay, so this happens. This is a technique. Whenever there is at least something, means I can consider the complementary case. Okay, can. So you see, without replacement, without replacement. So some students will think about, oh, very confusing, without replacement. So what happens if I take the vowel first, or the no vowel first, or the consonants, or the non-consonants first? I don't care. If you have understood what I said in the first part, I don't care. Whether it's a replacement, no replacement, everything I can still do it the same way. No order, counting. 1 minus number of required over number of total. So the required ways is no vowels, right? So the 4 cards, no vowels. So there's 5 consonants. Out of the 5 consonants, I need to choose 4 of them because there's no vowels. Okay. Over the total will be simply 8 choose 4. Gives me the answer. 13 over 14. Do I need to care what consonant, 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 consonant? Or if I consonant L, consonant no L? I don't care. Just no order. I never do any arrangement. I don't even care about the repeated L's or no repeated L's. This, so ladies and gentlemen, is the essence. Okay. So for the last question, part 2. Record the letter and the card drawn. On a piece of paper, if the card is drawn, it's a vowel, Tom will put the card back. Okay. If the drawn is a consonant, he will remove the card from subsequent draws. You find the probability that more consonants and vowels at the end of 3 draws. Okay, can. So if it is 3 draws, for that to have more consonant than vowels, okay, there can only be 2 combinations. The first combination, of course, is consonant, consonant, consonant. The second combination is I have 2 consonant and 1 vowel. So for the 2 consonant and 1 vowel, okay, can, if let's say I decided to do it with order, also can. Okay, then I need to consider it can be consonant, consonant, vowel, consonant, vowel, consonant, or vowel, consonant, consonant. Okay, can. So today, in order to compute all this, okay, we can also use the tree diagram to help us. Okay, if let's say I want to consider the order. So for the consonant, 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 so probability of consonant, 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 plus probability of consonant, consonant, vowel, plus probability of consonant, vowel, consonant, plus probability of vowel, consonant, consonant. So if it is consonant, 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 okay, the probability will be 5 out of 8 times 4 out of 7 times 3 out of 6, correct? Because as I draw down the consonant, you go 5, 4, 3. Same thing for the total will be 8, 7, 6. If it is consonant, vowel, if it is consonant, consonant, vowel, it will be 5 over 8 times 4 over 7 times 3 over 6. Plus, if it is consonant, vowel, consonant, it will be 5 out of 8 times 3 out of 7 times 4 out of 7. Plus, if it is vowel, consonant, consonant, it will be 3 out of 8 times 5 out of 8 times 4 out of 7. If you add all this up, it will give you 0.644. Okay, can. So you see, if I don't want to do it this method, can or not? Can. Can you use back the same method as part 1? Can also. But purposely over here, I show you that the same question can be done in different ways. Okay, so don't be confused. Choose the most viable method for yourself and use it. Okay, and most importantly, when you do your probability, assume that you are correct. Move on. Give yourself 10 minutes to think about that 8 or 7 mark question. If I don't get it, does it matter? It doesn't matter. It's out 8 out of the 60 statistics part B section, which is 8 out of 200 marks. Does it matter? It really doesn't matter. Okay, can. So thank you everybody for attending my very first lesson. All right, I hope to produce more and better videos, okay, to help you in your learning. Okay, and of course, if you need guidance, if you need more guidance, you can always engage me. Thank you so much. Have a good day.